Welcome to today's class. Today we'll be discussing probability. We'll be talking about events and outcomes. What do you mean by an event? What do you mean by outcomes in the topic probability? So let's talk about event. When an experiment is performed, two or more results or outcomes will be expected to happen. Each attempt is called a trial, and the outcome of a trial is usually denoted by E. Now, when we talk about an event in this topic probability, for instance, when you throw a die, consider a die that you used to play Ludo. When you throw one of the die or one of the dice, and you just throw one, you expect that it shows a 1, a 2, a 3, a 4, or a 5. Now, because you have thrown, you have done something, you are experimenting, that act of throwing is called experiment. Now, if you throw the die like once, twice, thrice, now each action of throwing is called a trial. Now, when you throw the die 3 times, it means you have 3 trials in the experiment. Do you get that? Now, what do you call an event? We expect that when you throw one die, it shows a 1, a 2, a 3, or 4, a 4, or a 5, or a 6. But if it shows 1, it means that the outcome of the experiment is 1. So therefore, the event is that the die shows 1. So the event is the outcome of a trial or the outcome of an experiment. Do you understand? The result obtained is termed the event. So what do you mean by random experiment? A random experiment is a repetitive process. So when you repeat the process of the experiment, you call it random experiment, which may result in any of the possible outcomes, that is the event. Alright, so let's talk about sample space. Sample space is a set containing all the possible outcomes you could have in an experiment. For instance, when you throw a die again, you have either 1, 2, 3, 4, 5, or 6. So therefore, 1, 2, 3, 4, 5, or 6 is the element contained in S, because this is a set of all the elements that could be shown. For instance, if you throw a die, you cannot have 7. 7 cannot be in the sample space. Can you see that? But 6 can be in the sample space, even if the outcome is not 6. The outcome could be anything. The event could be 1, 2, or 3, or 4, or anything from 1 to 6. But the outcome cannot be 10, because 10 is not in the sample space. I believe that's clear to you now. Right, so let's quickly talk about some examples here. When the coin is tossed twice, all the possible outcomes, that is the sample space, is when you toss a coin once, the normal coin that the coin we spend in the olden days, right? You can't have 2 parts of it. The first part is called the head, where a man is drawn. The other part is called the tail, where we inscribe the Nigerian coat of arms. So we have the head and the tail. Now, when you throw 2 dice, you don't have the first one showing a head and the second one a head, or the first one showing a head, the other one a tail, or the first one showing a tail, the other one a head, or the first one showing a tail and the other one a tail. So you have 4 elements in the sample space. Can you see? So you have, when a coin is tossed twice, all the possible outcomes, that is sample space. Sample space is a set containing all possible outcomes. Sample space S is a set of HH, meaning head head, head tail, tail head, or tail tail. So therefore, the number of elements in sample space, which is n into s, equals to what? 4. Therefore, n into s is 4. Now, if a die is cast once, if you cast or you throw a die once, what is the sample space? I discussed this earlier. The sample space will be what? 1, 2, 3, 4, 5, or 6. Therefore, the number of elements in that is 1, 2, 3, 4. If you add them together, 1, 2, 3, 4, 5, 6, you have 6. Like if you count, not add now, sorry, when you count, you have 6. Here, when you count, you have 4. Number 1, you have 4. When you count here, you have 6. When you count here, you have 4. Alright, so sample space is 6. Suppose an event E, that an even number is thrown. Now, if you are asked that, okay, what will be the number of events if a die is thrown? That is, if it shows an even number. Suppose that an event whereby that event is that the die shows an even number. What will be the number of elements in the event? There will be 3, because it means the die could show 2, 4, or 6. 2, 4, or 6. So if you count 2, 1, 4, that's 2, 3, 6 is 3, making 3. So the number of elements in E will be 3. Don't forget that E is the outcome. The outcome here is that it shows an even number, while the sample space is all possible outcomes. Okay, number 3 example says a box contains 16 red, 6 white, and 18 blue balls. 18 blue, not blue balls, sorry, 18 blue balls. Now, what is the sample space there? You add 16 plus 6 plus 18, that gives you 40. Therefore, cardinality of S is 40. That is, the sample space contains 40 elements. Number 4, when a die is tossed twice. When a die is tossed twice, the outcome of the first toss is S1. That's what that shows 1, 2, 3, 4, 5, or 6. Does not influence the outcome of the second throw, which is what S2. It could be what? Same thing, 1, 2, 3, 4, 5, or 6. It means when you throw one die, because one die shows 6, does not mean the other die will show 6. One could show 5, the other could show 7. Could show 6 or 1. 7 cannot be there because 7 is not in the sample space. Therefore, because these two dice can show their own and give out outcomes irrespective of what the other gives, we call this experiment, you say they are what? Independent experiments, or that the outcomes are independent of themselves. Do you understand? So for instance, the chance of throwing a 5 in the first toss, this if you toss the first die, is 1 out of 6. The probability is 1 out of 6. That is, if it's to show a 5, don't forget it could also show 1, 2, 3, 4, 5, 6, making 6, but it's showing a 5, that is 1. Probability that it shows a 1 is 1, a 5 is 1 out of 6. It does not influence the chance of the throw of 2 in the second toss. That is, if 2 shows in the second die when you toss it, that does not affect the other one in the first one. So it's still 1 over 6 because we only have 1, 2 out of the 6 outcomes it could have. They are independent events or independent probabilities. Now, equally likely events. What do you mean by equally likely events? 2 or more events are said to be equally likely to happen if the chance of occurrence of each of them is same. Now, for instance, in the throw of a die, there are 6 equally likely outcomes. Either you have 1 to 6. The chance of each occurring is 1 out of 6. Do you get that? So the chance of you having 1 when you throw a die is 1 over 6. Having 2 is 1 over 6. Having 3 is 1 over 6. So we call them equally likely events because they have equal chance of occurring. It's a fair chance, a fair play. Now, also we have from a pack of 52 cards. From a pack of 52 cards, the chance of picking any of the cards at random is 1 out of 52. So 1 over 52. Do you understand? So then what is probability? We understand the term chance. We understand the term equally likely events. We know what event means. We know what they call outcome. We know what they call sample space. And we know what they call trial. So now what is probability? The probability of an event is the chance of its occurrence. That is the likelihood of the event happening with respect to the sample space. The ratio of number of events over number of sample space is called probability. It is the chance. For instance, you can define probability as NE over NS, that is number of elements required or number of required outcomes over number of all possible outcomes. Number of elements in E over number of total elements in S. Some people can say the probability is defined as the number of required outcomes or events over total number of all possible outcomes. Note that probability of an event lies between 0 and 1. That is, 0 is less than P of E, less than or equal to 1. Then probability that it will not occur is 1 minus P of E. Now listen up. Probability of an event lies between 0 and 1. So you cannot have a probability as 2 or 2 point something no or 1 point something no. It is that 0. If the probability is 0, it means that thing can never happen. For instance, the probability that the age of a boy reduces is 0. Age will always increase. Now, the probability that it will rain tomorrow is 0.5. It could rain tomorrow, it might not rain tomorrow. So, it cannot be more than 1. If probability is 1, then it means it's going to happen. For instance, the probability that a boy's age will increase by 1 day after 1 day is 1, is certain, because after the boy spends a day, his age increases by a day as well. So that is probability of certainty as 1. When something is sure to happen, the probability is 1. When it is sure that it can never happen, the probability is 0. Now, the probability that it will not occur is 1 minus probability of it occurring. If the probability of it occurring is known, then the probability that it not occur is 1 minus that it will occur. Do you understand? Alright, so for this class we'll stop here. Let's take our evaluation. In the class of 27 boys, and 12 girls, what is the probability of picking a girl? Now, I won't tell you that. Probability of picking a girl, we want a girl. Now, don't forget that how many boys do you have? 27. How many girls do you have? 12 girls. So what's our sample space? Always get sample space first, not probability questions. 27 plus 12, that's what? 39. We have 39 people in the class. If you pick one girl, that'll be what? Number of girls over total number of people in the class. How many girls do you have there? 12. So our probability is what? 12 over what? 27. Now, if the question is changed that what is the probability of picking a boy, it will be what? Number of boys, which is the outcome we expect, boys. That's the event that it shows a boy. Can you see that? That we pick a boy. So number of the boys over total number of people. That's 27 over what? It's 9. Always give probability to the lowest term you cut if possible, but don't leave it as okay, just lowest term. Now 2. A number is chosen at random from 40 to 50. Find the probability that it is a prime number. Fine. In this case, you find your S first. What's your S? What is your sample space here? We have 40 to 50. 40 to 50. Now 40 is inclusive, then 41, 40, that's 11. 11 is sample space. Find the probability that it is a prime number. Now you find the prime numbers between 40 to 50. I want to tell you that now if you have 5 prime numbers there, so your probability will be what? Probability will be what? Number of prime numbers over total number in the sample space. If you have 5 prime numbers, you have 5 over 11. So you can go find out that yourself. You know what prime numbers are? Numbers that cannot be divided by any other number except for itself and 1, like 41, 43, etc. Find it by yourself. Now, number 3. If all 2-digit numbers 0, 0, 0, 1, 0, 2 up to 99 are equally likely to be chosen, find the probability that a number picked at random has 5 as its first digit. So you must find all the numbers that has 5 as their first digit first. Like an example is what? 50, 51, 52, 53. Find everything between 0, 0, 0, 1. Then your sample space should be what? From 0, 1 to 99 alone is 99. Now because 0, 0 is there, you have 100. So your 100 is a what? Sample space. Now to find the probability, you need to look for what is the required outcome, what is the event we are involved in. Find probability that a number picked at random has 5 as its first digit. That is the event, that it has 5 as its first digit. So look for number that has that fulfill that condition, starting from what? 50. Now 5 does not have 5 as its first digit because it is 0, 5. Can you see that? So you look for everything. Alright, so I hope the class is clear. Do have a nice time. Thank you.